For this week, I chose to do problem number 37 from chapter 11. And this problem revolves around the game of Chuck-a-Luck, a chance game that involves 3 die and choosing a number between 1 and 6. So the game goes like this. You choose a number before rolling the die, 1 through 6. You roll the 3 die. If any of the die match your number that you chose, you win. However, if none of the die match the number you chose, you lose. And there are 4 different results that can come about from winning and losing. If none of the die match your chosen number, you lose $1. If one of the die matches your chosen number, you win $1. If 2 match, you win $2. If 3 match, you win $3. So for this example, I decided to not use at risk, but rather just use the rand between function on Excel. And I have 4 different random variables that I want to look at. First being the number chosen, 1 through 6. I wanted to have an equal amount of options between 1 through 6. And then also random for the 3 die that are being cast. So I've actually pulled out the rand between equations here because I just did a copy and paste of special values. But I have rand between for number chosen and then the 3 die. And now I also have to have equations to account for the results for each of these tosses that we're looking at. So I have 3 win die columns looking at the 3 individual die and whether we won on each one of those. And they're all essentially the same. Win die 1 is if the die 1 cell matches the number chosen cell, and if they do match, we win $1, but if they don't match, we essentially have $0. And we do the same thing for win die 2 and win die 3 columns. Finally, we have the lose column. So if none of these 3 die match the number chosen, we're going to lose. And I represent that by an if function, saying that if the sum of the 3 win columns is greater than 0, then obviously we're going to lose $0. However, if that sum is not greater than 0, we're going to lose $1. And finally, we have our final result in the total 1 column. And this is simply just a sum of the columns F through I, whether we've won or whether we've lost on this toss. So I ran this simulation 1,000 times. All the way down here, you can only see 15, but I ran this one 1,000 times and then aggregated the results here. So we have our summary results. The problem just asked to find us what the average result would be for this game. And from my simulation result, here's our equation here. I summed the total 1 column, just J5 through J1004, and then divided by the number of tosses, which was 1,000 in this case. We get an average result of -6 cents. So it shows on average that this is not a winning game for the player. You're more likely to lose than you are to win. And this shows here with our probability to win, greater probability of losing. And then I also wanted to demonstrate the number of occurrences for the 4 different possibilities. So we have occurrences of -$1, $1, $2, and $3. And obviously the greater majority falls on this -$1 since there's a greater probability of losing. Next greatest probability is winning $1, so just having 1 die match your number chosen. Next is $2, and there's a very slim chance of winning $3 on any of these tosses. And this simulation was just 4 out of 1,000 tries. So in order to kind of corroborate my results, I ended up doing the simulation 5 times, so I just ran the numbers. I just did the simulation 5,000 times, essentially. Just did it across 5 different tabs here. So in this one, we have a probability to win of 0.435, average results of -6 cents. Simulation 2, probability of 0.413, -10 cents. Third one is 0.429 with a -8 cents. This was actually our worst here with a probability to win of 0.39, losing 14 cents on average per toss. And then finally, probability of win of 0.424 with an average result of -7 cents. So by running this simulation 5,000 times, we can see that the average result is losing, slightly less than 0, but we're still losing on average.